പോയ്സോൺ ഇൻ്റഗ്രൽ ഫോർമുല പ്രൂഫ് പറയാം. മുന്നേ ഇതിൻ്റെ സ്റ്റേറ്റ്മെൻറ്റ് മാത്രം ഇട്ടിരുന്നു. ഇതിൻ്റെ പ്രൂഫ് ഒരു ക്വസ്റ്റ്യൻ പേപ്പറിൽ കണ്ടുകൊണ്ടാണ് ഇപ്പോൾ ഈ പ്രൂഫും കൂടെ ഇടുന്നത്. ഇപ്പോൾ എഫ് ഓഫ് സെറ്റ് ഈസ് അനലിറ്റിക് വിത്തിൻ ആൻഡ് ഓൺ എ സർക്കിൾ സി defined by mod z equal to r, and if a is any point within c, then f of a is equal to 1 by 2 pi integral over c r square minus a conjugate f of z dz by z minus a r square minus z a conjugate. Hence deduce the Poisson formula f of r e raised to I theta is equal to 1 by 2 pi I integral from 0 to 2 pi r square minus r square f of r e raised to I pi d pi by r square minus 2rr cos theta minus pi plus r square, where a is equal to r e raised to I theta is any point inside the circle modulus of z is equal to r. Proof. Suppose f of z is analytic within and on the circle defined by mod z equal to r, and a equal to r e raised to I theta is any point inside C, so that 0 less than or less than capital R. See this figure. The circle C mod z equal to r, that is a circle with the center 0 and a radius r, and A is a point inside C. A equal to r e raised to I theta, that is modulus of a equal to r, modulus of a equal to r, which is less than capital R, which is less than the radius of the circle, that is written 0 less than r less than capital R. And we have to define a new thing, that is inverse of a point. The inverse of a point A with respect to the circle C is the point A dash lying on the same ray from the origin and satisfying the condition modulus of A dash into modulus of A equal to R square. That is, the point A is inside the circle, and the point A dash, that is the inverse of A, is lying on the same ray, same straight line as A, and with the condition modulus of A into modulus of A dash is equal to capital R square. And because capital R by R is greater than 1, that is capital R by R is greater than R, then capital R by R is greater than 1, modulus of A dash is equal to R square by modulus of A, because R square is equal to modulus of A dash into modulus of A, then modulus of A dash is equal to capital R square by modulus of A, then it can be written as capital R by R into R. Since R by R is greater than 1, it is clearly greater than R. And modulus of A dash is greater than R means A dash lies outside the circle, because modulus of A dash is greater than the radius of the circle. Then by Cauchy's integral formula, f of a equal to 1 by 2 pi I integral over c f of z by z minus a dz. Since f of z is analytic within and on the circle, and so f of z by z minus a dash is analytic within and on the circle C, because a dash is outside the circle C, then f of z by z minus a dash is analytic within and on C. And by Cauchy's theorem, integral over C f of z by z minus a dash dz is equal to 0. And this 0 quantity is incorporated with this. Then we can write, that is 1 minus 2. 1 is the first equation, Cauchy's integral formula, and 2 is the equation, Cauchy's theorem. Then 1 minus 2 becomes f of a equal to 1 by 2 pi integral over c f of z by z minus a minus f of z minus a dash, f of z by z minus a dash. this f of z by z minus a dash integral over c f of z by z minus a dash dz is equal to 0. Hence, we can write it in this fashion. And by simplifying this, by taking the LCM and simplifying, we will get f of a equal to 1 by 2 pi a integral over c a minus a dash f of z dz by z minus a into z minus a dash. Then we can replace a dash by r square by a conjugate, because a conjugate a dash is also equal to r square. We can show then 1 by 2 pi I into a minus r square by a conjugate f of z dz by z minus a, z minus a dash is replaced by r square by a conjugate, and numerator we can again simplify 1 by 2 pi integral over c a dash r square f of z by dz by a conjugate, then z minus a into a dash a conjugate z minus r square. Then the denominator become cancelled, that is a conjugate is become cancelled. Then f of a equal to 1 by 2 pi I r square, you invert r square minus a dash, then there is a minus f of z by dz z minus a, then here the denominator this factor also inverted, that is r square minus a dash a conjugate z, there is a minus and minus into numerator minus become plus. Then any point z on modulus of z equal to r is expressible as z equal to r e raised to I phi. Any point on the circle mod z equal to r can be expressed as mod z equal to capital R e raised to I phi. Capital R is the radius, and this is the representation of a point on the circle. Also, a equal to r e raised to I theta. Then a conjugate is r e raised to minus I theta. Then r square into a conjugate is equal to r square minus r square, because a into a conjugate is equal to r square. And this is the equation number 4. Then z minus a into capital R square minus z a conjugate becomes r square. By expanding this, r square z minus z square a conjugate minus r square a plus z a conjugate. Then you replace z is equal to r e raised to I phi and a equal to small r e raised to I theta and a conjugate by e raised to minus I theta. It becomes r square into r e raised to I phi minus r square into e raised to I 2 phi. Z square is r e raised to I phi, then s square is equal to r square into e raised to I 2 phi, a conjugate r e raised to minus I theta, r square a, r square r e raised to I theta, z a conjugate, that becomes r e raised to I phi, r e raised to I theta, r e raised to minus I theta. Then by taking outside the common element r e raised to I phi from all the terms, it becomes r e raised to I phi into r square minus r e raised to I phi minus theta. Then third, r e raised to minus I phi minus theta. There is no phi e raised to I phi here. I phi, if you take outside r e raised to I phi, you have to multiply by r e raised to minus I phi, hence this term, plus r square, then e raised to I theta into e raised to minus I theta, that becomes 1. Then taking outside capital R e raised to I phi, the remaining term is r square, and that is equal to capital R e raised to I phi into r square minus 2r minus 2r. These two terms becomes combined, minus 2r cos phi minus theta, because e raised to I theta is cos theta plus I sin theta. Then e raised to I theta minus phi minus theta. Phi minus theta, that is cos theta, cos phi minus theta plus I sin phi minus theta. Then here also minus I phi minus theta is cos phi minus theta minus I sin phi minus theta. Then combining this and using the results in trigonometry, we will have 2rr cos phi minus theta plus r square. Then dz is equal to z is equal to r e raised to I phi. Then dz is equal to d of r e raised to I phi, that is r into I into e raised to I phi d phi. Then this is the equation number 6. And rewriting 3 with the help of 4, 5 and 6. 3 is, where is 3? 3 is this. F of a equal to 1 by 2 pi I integral over c r square minus a conjugate f of z dz by z minus a conjugate z. Then the denominator is simplified r square minus a conjugate as this 5 and dz, or z terms are replaced by theta and phi. Then we will get f of a equal to 1 by 2 pi I r square minus r square. This is r square minus r square f of z r e raised to I phi d phi is r square minus r square, because a conjugate is small r square. F of z, z is equal to r e raised to I theta. Dz is equal to I, what is dz? R I e raised to I phi d phi. All these are replaced and we will get f of a equal to 1 by 2 pi I, the integral from 0 to 2 pi r square minus r square f of z by into r e raised to I phi I d phi by r square minus 2rr cos theta minus phi plus r square r e raised to I phi. And cancelling out the common terms from the numerator and denominator, we will get 1 by 2 pi integral from 0 to 2 pi r square minus r square. F of z, z is replaced by r e raised to I phi. R e raised to I phi, r e raised to I phi get cancel. I and 2 pi I ലുള്ള I cancel ചെയ്യും. And the remaining, the integral becomes 1 by 2 pi into integral from 0 to 2 pi r square minus r square f of capital R e raised to I phi d phi by r square minus 2rr cos theta minus phi plus r square. Hence the proof.